All right, so the next thing we need to do is pick a winner. This is less of a data structure um, need per se than it is just kind of a fun little exercise. But it does tie into the fact of how different data structures might be easier or more difficult to work with given a structure. So the idea is to pick a random number. And so the random feature in Java control space here, java.util.random. I'm just going to call it R because I don't need a fancy name for this. R is good enough to think of random. I don't always like one-letter variables, but in some cases like this, it's like the only thing that can make sense. So I'm going to create a new random object from that. And so then I want to say the winner, if you will, is going to be equal to the r.nextInt within a boundary. So what this function does is it picks between 0 and some number, and that number is going to be our I'm going to call number of eligible entries between 0 and the number of eligible entries. All right. So it doesn't matter what number I'm picking. I theoretically could pick. Sorry, I have to call the function right here. So I could pick specifically the number, but what if not every number in numerical order was submitted? The tickets normally start at some sort of 6-digit number, and not every some could be lost, some could be never submitted, some could just be never submitted. So I don't know. I mean, I could have different people sell some could never be sold. So it's easier just to pick a ticket random, and the random could be just whatever number I have out there in the eligible tickets. But the problem there is I'm supposed to remove that ticket as well. And so I don't really have a very easy way necessarily to remove from a set. So again, I had unique submissions, so there's not really a remove method with some sort of index involved inside of here. So there's a couple different ways I could do. I could take those unique submissions, I could pull one out at random from a list or an array or something else, and then pull it back out of the original one. That's a perfectly reasonable thing to do. I could also have something, but that means I have to have 2 copies of that data structure along the line as well. So the other thing I can do is I can use the iterator. So this is a little bit of less clean Java code than originally you could have done with the nice Java for loop, but you can't remove from a nice Java for loop. So I can do for iterator of tickets I is equal to unique submissions, dot iterator I dot has next, and I don't need any third. So I'm going to loop through that as long as I dot has next. I can do this with the while loop as well. The structure of the for loop is kind of nice because it shows me the same structure going on inside of here. And so I can say int count is equal to 0. And so if count is equal to the winner, could be 0 out there, then I'm going to say ticket winner, let's say winning ticket, so I can distinguish from the integer winner up there. Remember, I had to find winner up here. I can't have it twice. So the winning ticket is equal to I dot remove. So the iterator gives me this call to remove that ticket, and I can both take it out and return it, the winning ticket, at the same time. Now, I could just say return I dot remove, but let's see. Oh, is that? Oh, sorry. Maybe equal to I dot remove does not actually return. They already have the item there. Oops, I dot next. Excuse me. And actually, I need to do I dot next on every single time, because if I don't, then I'm only going to go loop through the iterator here. But I dot next needs to happen every single time, and then count is equal to count plus 1 every single time. But I can put this I dot next up here to finish my loop structure. Oh, no, I can't do that. I can do that, but I'm going to put it down here just to make it a little bit clearer. I don't love this use of the for loop around here. Honestly, I like the while loop better, but I'm trying it out because this is a common structure I've seen. So let's see how it works. And otherwise, this is return null because it's going to be an error case. I didn't find anything. I pretty much should find something every single time, but if I don't for some reason, if for some reason something breaks, then it should work that way. So let's see if this works now. I'm going to run this again, and it does seem to pick, and it does seem to pass. Now, I'm skeptical that this test case is doing what I think it's doing, but I'm not going to debug it here. I might take a look at it and update it before you see it. But right now, if it says it passes good enough. So that is the pick function. Now, again, not a super data structure-y type thing, but it does give us some little challenge in Java data structures of how do I manage and deal with those. All right, so I'm going to leave this here, let you build this one, see if you get this to pass. Again, you should have some code inside of here. If you just say, hey, it passed, I'm not going to write any code there, then, hopefully my test case doesn't do that by the time you see it. But there's always a chance that if I don't see something that looks reasonable, I might have you be redoing that, something that does take a good shot at it. But in general, if it passes the test case, you're okay to submit it. All right. So take a shot at this, and then we'll do this last bit, which is the tricky part, where the maps might be coming in as a useful answer, was getting all the submissions for some ID. All right, so we're going to do that in a little bit, and we'll go from there.